Alrighty, it's about 6 o'clock, a little after, 6:05. Hello everyone, welcome to Game Dev Unity Workshop. Woo! As some of you may know, my name is Michael. I'm a project lead here. My game works in Unity, so that's why I'm here to do the Unity Workshop. Makes sense, doesn't it? Uh, how many of you guys have ever touched Unity before? Okay, a good number. How many of you guys have touched Unity 6.0 specifically? Okay. I mean, your games might be changing versions a lot too, because they're always developing. Unity is one of those engines that's always growing, it's always updating. So yeah, why Unity? Well, like I was explaining, it's very, very active. They're always updating it. They're always making changes and they're always making it better. Versus other engines, I mean, it's just an option. And this one just happens to have a lot of online documentation. So if you don't know what to do, you can look things up. And that's one of the best skills that you can possibly learn, is how to look something up. All right. Oh, I just realized my screen is so awkward over here. One second. I'll be ready in just a second. All right, there we go. Now, I'm going to go and start from the beginning, in case people don't know what Unity is and have never worked in Unity. This here is Unity Hub. When you download Unity from the Unity webpage, you get Unity Hub. Now, this isn't actually your engine. This is just simply a launchpad for your engine. So as you can see on Unity Hub, I have two projects on this device. One of them was what I was using to prepare this, and the other one is the thing I'll be using to show it to you. But I'll show you how to make a project too, because you'll probably have to download the version, and I'm going to explain things about downloads. If you go to a new project, you can see that Unity has a lot of different kinds of projects. And a lot of these are very advanced and not for this workshop. So what we're going to be doing is Universal 2D. We're going to be using the 6.0 version, that's what this whole thing is, but specifically the 0.57F1 version. You know, you can just find a good location for it. I wouldn't recommend putting it into your OneDrive for school, because these things are pretty big and can bloat your files pretty hard if you put it into an online repository like OneDrive. So just maybe keep that in mind. Maybe keep it on local for now. Move it to GitHub later or whatever. You can name your project, and if you have an organization like a school or company, you can put that here. I evidently am not in an organization. I am very unemployed. And then you can just use create project, and it would create a project. Very simple stuff. And that's Unity Hub. That's quite simple. Yeah, thank you. Unity Workshop was all about Hub. We're not touching Unity at all. Woohoo! Yeah, now you get to go and explore Unity Hub on your own. No, but here is the actual Unity. This is the actual engine. The reason I was asking about if anyone had experience in Unity 6.0 is because in recent versions of Unity 6.0, you might have seen something along the lines of this, like, gibberish here, the default volume input system and the universal things. I'll get to input system today. The other stuff we won't touch. But I'll explain what this is. Otherwise, let me explain to you what you're looking at. This is Unity, the actual engine. This over here is basically your file explorer. It's the exact same thing as a regular file explorer. It just looks prettier. So if I open up a regular file explorer, it would show you the exact same files that I would be able to find in this project if I had it opened, which I didn't actually preemptively do. Yeah, SFSU. Like, for instance, this is what Hello World's project looks like. Very similar in stuff. Anyways, other than that, it's just a file explorer. You can create files, you can remove files, you can open files, same thing. Over here is kind of like your scene observation thing. You can see what's in the scene. Any of these things, these are called objects. And I'll explain how to create objects and what they are and what they do. And this over here would show components if I clicked on an object, like this. These are components. Now that you know what everything looks like, let me explain things a little slower of what everything actually is. So let's start back with the File Explorer. We can open up any sort of these folders and see what's inside. And you can just create things like you would a normal File Explorer. Hopefully I don't have to teach you how to use File Explorer, but feel free to raise your hand and I'll explain it anyways. I'm just going to create a folder for later, and we're going to call it the scripts folder. We're going to put some scripts in there later, so I hope I'm going to try and explain computer science in the most non-computer science way possible, but to some degree, to make something work, you're going to need a little bit of computer science. That's true. Hopefully, by the end of this, you'll have a bare minimum prototype that you can copy the code from and have a working game. So even if you're not a computer scientist, you can make something today, hopefully, is the plan. So let's go ahead and make sure we're in the right scene. So we're in sample scene, right? Yep. We can create objects. So just like how you would in the File Explorer, you can right-click to get this drop-down menu. And let's say I want to create a 2D object, and I want to create a circle sprite. Now that's really far and small, but if you zoom in, we have a circle. Yay! You can have children to this object. So if I right-click this circle, I add another 2D object. If I can actually click, ignore this, go away, please, thank you. And I add another 2D object. Let's give him a triangle hat. Now, my circle has a hat. And if I move the circle around, the hat comes with it, because the hat is part of the circle object. This is the most primitive way to make a sprite. If you're too lazy to buy asset sprite, you can just do this. But buy asset sprite, it's pretty cool. You can name things around. So instead of calling this circle, I can call this, let's say this is our player. Boom. Just like that, it updates on that left side. And now, instead of a circle, we have a player with the children of a triangle. And that's basically objects. There are plenty of different kinds of objects, and what I've just showed you now are just simple sprites. But if we wanted to add functionality to these sprites, well, that's where the components come in. Components are the types of things that this object is. And that was really wordy, but what essentially it means is it actually just like gives it effects and values. So let us start with making this, I don't know. We'll grab a script for it in a second, I think. Or a rigid body. Or we just make a script now. Why not? Let's give our player some functionality. We want to move it around, right? So we would create scripting mono behavior script. What the other ones are, I don't remember off the top of my head. But that's what Google's for. I'm just going to call this script player movement. I can't spell, apparently. It looks really ugly in terms of the name because it's a movement, but it's player movement, I promise. And we'll get back to this and explain how to actually code for this. But I promised I also explained the input systems, didn't I? So this is another thing on the Unity engine. Now I'm bouncing back between a lot of different things right now, but I promise it'll all come together. This is Unity's new way of getting controls for the character. It's a new way of getting controls for your from your keyboard to your character. So there was an old way to do it, two old ways to do it. One of them was hard coding into your code which button press does what. It would be like get key down or whatever. That means the only way to change that feature, that control, would be to enter the code and hard change it. It takes the ability away from the player. There was another system. It's named similarly to input action, but I think it's called like input system or something like that. Someone can correct me. And that fixed it, but was a little bit clunky to work with. This one's a little less clunky, but a little bit more complex. So I'm going to try and hope and break it down for you guys. So the one you find here, when you open up the project, this is what's called the universal controls. This means no matter what scene you're in, if you have these controls set, it would work. We're not going to use these. We're going to make our own. So if we just create a folder called controls, we can store all of our input system controls in there. This keeps things a little bit more organized than just having everything in the home page, but technically it doesn't have to be in any specific folder. You can name the folder whatever you want. You can name it Penguin folder if you really wish, but I would recommend keeping things a little bit explanatory. So let's go ahead and create an input action here and call these player controls. And let me move this down from the correct screen. Now we have an empty one. And let me explain to you what you see here. So, that's the name you gave it. That's pretty simple. Control schemes. This is how you decide what kind of devices your controls work for. So if I add a control scheme, I can name it. Let's say I want my keyboard and mouse set up, but I'm really only going to use the keyboard today. I can't spell at all. Mouse. And you can add, I have another drop-down menu, I'm sorry. It's all up here. Go down. This drop-down menu doesn't want to move. I did not plan for this. It comes with a little drop-down menu that has like a list of items on it, such as a keyboard, and you just click it and it adds it. I'm sorry the drop-down menu didn't show up, but yeah. So if you hit the plus button, you'll get a drop-down menu with a list of devices like keyboard, mouse, gamepad, joystick, such and such. You can select keyboard, and now you have a keyboard device for this control scheme. You can say whether or not it's required to use this control scheme. So if, let's say, it's an optional thing, you can unclick it. But since this is not optional and we need this keyboard controller thing, we're going to say it's required. I won't add a mouse for now. I'll save that for you guys. Now we're back here. Is everyone like good so far? I'm going a little fast. So if I ever need to pause for someone, just raise your hand. Get any questions? Raise your hand. I'll answer. You can add an action map. So what's an action map? Well, let's say you have the controls for your normal gameplay where you walk around the world and you use WASD for your normal movement. But let's say in your game you can hop into a tank and now you have tank controls where W and S move forward and backward, but A and D only make you rotate. They don't make you strafe left and right. So that's where action maps are. You can name an action map like, oh, this is the tank controls when you get into a tank. Or this is the regular gameplay controls. That's what these are. That's the difference between these two. Then we can move on to actions. We're going to get a little complicated in actions. There's a lot of different things you can do. Whatever you name your action, you're going to want to actually remember. So try not to make a typo here. This is a very big challenge for me today, apparently. Yeah, what's up?
Hypothetically, if I were to make a typo, would that be a syntax error?
If you made a typo here, it would be a semantic error because Unity will still compile it with your typo and will just treat the typo as your intended means of running it. But if you chose to, in your code, use what you actually intended, your actual intended wording would have been a syntax error. So let's name this movement. Or move so I can type faster. And what we're going to do is we can see what kind of action this is. Is it a button? Is it a value? Or is it a pass-through? Value is kind of like you can get vectors from it. And I guess if you're new to Unity, this doesn't make a lot of sense. But this is like, imagine a control. I could just draw this actually. You want to see my drawing skills? This will be fun. Do we have Paint, MS Paint in here? Yeah, we do.
Except without all the.
Paint software, awesome. I wasn't exactly planning to do this, but why not? So imagine you have a square. Wow, that's convenient. In your square, it has a simple layout. If I can draw a line of a plus sign and ticks for values. This is your normal graph, an XY graph. If you're a control, I can't, guys, I can't. This is so difficult. You're so right. You can tell I don't draw. You're so right. Okay, so you have a normal XY grid. Let's say I bound up to W, S, A, and D, like, you know, your normal WSD controls. A vector would basically be getting you the direction it's going in. It would give you it'd give you something like that, your normal like vector math thing. So I hope you guys took vector math. Okay. Well, okay. Well, a vector has a magnitude and a direction. Basically, your direction is x and y, and you have to figure it out yourself. And your magnitude is a number. I'll go back to that. Where is cool? So, you know, versus a button that's just a button. It could be so simple and it could be so complicated sometimes. So because this is our movement, we're going to want to do a value because we want that WASD control. We don't just want one button. And we're going to make sure it is a vector 2. Vector 3 is if we had a 3-dimensional space we're working in a 2D project. But if you're working in a 3D project, you're going to need a vector 3. Okay, now what is this? This is a binding. This binds the action to a button. So, oh, the list is in the top corner of my screen again. You don't get to see it. Oh, I wish I could move this. Can I like do Windows? No, it doesn't let me move it at all. Well, let me just quickly put something in there. Listen, W. Why is you not? Well, I tried, but it wouldn't let me, so I'm just trying to put something in it, and it's also not letting me. So we'll get back to that. Oh, that's why. Okay, I got that. I didn't mean to do that. Well, now we're gonna go over the process of doing it again. Give me a quick second to name this move again. We're going to give this action a up, down, left, right composite. That's a lot of words and a lot of confusion. But it's honestly really simple. So a binding is just one button. You can say, oh, this button is A, this button is Q. Doesn't really matter. A positive negative binding, if you want to go back to our wonderful MS Paint, is just the x-axis. Oh, nope, that's the wrong one. What else is there? Keep going. Up, down, left, right, forward, backward composite is the normal x-y axis, but in the z-axis. I think in actual like 3D math, this is wrong, and like z is like up here or something like that. I don't remember. I didn't do 3D math. Huh? Y is still up? I heard like different things from different people from different teachers. So I know in Minecraft Y is still up. Huh? Z adds depth. Okay, cool. Then you have binding with modifiers. We're just gonna add an up, down, left, right composite. And remove whatever this is. Thanks. Okay, now we have a 2D vector. I explained what a 2D vector is. It's this. But you have another option here. Analog, digital, normalized, or digital. Now, what does that mean? Is there a nuke button for Paint? Does anyone know?
Delete everybody.
Yeah.
Control A, delete.
Control A, delete. Awesome. Thank you. So, you've got digital, which is the square that I showed you earlier. This is digital. Oh. Yes, I will try. I don't know how to use MS Paint. Is the brush thicker? Yeah, it's thicker. All right. So, gosh darn it. So, a digital is your normal square. But if you do a little bit of math, if you're holding direction 1 over here, and you're also holding direction 1 over here, your vector comes out something like this. That's a little further than the other ones, right? This comes out to be about like 1.4 in magnitude. So that's a little wrong, because that means you're going a little bit further on the corners, which if you just take the value from your vector, means you're going a little faster. Has anyone played those games where you can go a little faster in the diagonals? That's why. So the way that Unity gave us an out to that was called digital normalized. Please go back to my Paint 3D. Digital normalized just means if you're holding the corner, instead of 1.4, it's more like actually 1, which comes out to be like 0.7 on both ends. I guess this isn't the 1 or whatever. Yeah, comes out to be like negative 0.7 on the two ends, which ends up being 1 in magnitude. But that's basically, instead of a square, you now have 1, 2, 3, 4 octagon. That's what digital normalized mean. Analog means a circle. It's like an analog joystick. It makes sense. Yeah. So we're gonna use digital normalized because I didn't bring a controller with me. I guess we could use analog if you want. No, we'll play around with that later. So if you hit the drop-down menu, now you can see all 4 of these bindings. When I created this up, down, left, right composite, it takes these 4 bindings and makes a composite of whatever combination that I am holding down. It means combining the values a little bit. So let's give those directions an actual binding. You know, let's use a very normal control for an up, down, left, right. The arrow keys now, WASD. Okay, fine. JKIL. So the drop-down menu isn't showing up on the bottom screen, and I can't make it. But trust me, if you click this, it creates a drop-down menu, and you can search a key, or you can hit the little tiny listen button in the top right corner. I can't show you the little tiny listen button in the top right corner, but it has one. So, you know, I'm gonna hit listen, I'm gonna hit S on my keyboard, and it comes up with the S key down. Or of course, you can just do searching it. So again, you can hit this. In the search bar that I can't show you, but I promise you is there, I can hit A, and look for the A on the keyboard. Whatever way works for you is whatever way you can do. And it's good to learn both of them in case you can't find it or you can't listen for it. Now we have our controls. What the heck does global mean? It says keyboard global. Well, if our up, it means up direction is bound to our W on the keyboard, but it means it's global for all of our control schemes, which would be weird if we had a gamepad. I don't know of a WASD on a gamepad. So we're going to want to make sure we know which control scheme it's for. This specific keybind is for keyboard and mouse. This little checkbox here, and that turns off the little global thing. All right, that's input actions. Does that make sense? So all we've done is we've just created a control scheme for a device. We've made an action map by defining what kind of gameplay it's for. We've then created the actions of move with a value of a 2D vector, and have given it buttons to bind with. You can actually change these in the code, meaning you can give the player the ability to make their own controls. Isn't that nice? This is better than hard coding it, because we can't have self-modifying code. So that's why we do it this way if you want to. It's very helpful. Make sure you save. You can hit the autosave button, or you hit Control S, or you hit Save As if they all work. Autosave just means if you're doing the edits, it'll autosave it. Wow, it's almost like we name things very clearly. All right. If I wanted to add more actions, you just hit the plus button, and then you would just start up a new action. So if I wanted to do jump, I can bind that to a button, whatever I want. But why don't I save that for later and just show you what we can do with this. Let's go back to our player. I hinted a little bit that we can add components to give this a little bit of functionality. So if I want to use my controls on this player object, I'm going to add a component for that. I believe it's just called input. Nope, not called input because I spelled it wrong. Input action. Input something. Hold up. I'll figure out what it is in just a second. There's like a bajillion different component options, and I want to make sure I do the right one for this. It is a player input. Player input. There we go. Or nope, wrong one. Not input manager. I think they do mostly the same thing, but can do different things in certain areas. Off the top of my head, which one does what, I don't remember. Player input. There we go. All right. Now what do we see? Well, we see a warning. Project-wide action asset is not recommended to be used with player input because it is a singleton reference and all actions maps that are enabled by default. You should manually disable all actions and maps on start and manually enable an action. Whatever. We're just going to ignore all of that and choose a different thing. What's really cool about Unity, if you use the file explorer down here, is you can click and drag if your thing allows you to use that kind of file in here. So I'm going to click and drag the player controls that I just made into that little section there where I can put in any input action system control, and boom. Look, the warning's gone. That's nice. All right, so now it means that I've bound these controls to this player input. I can choose which control scheme to use if I want to default it to something, or auto switches between two different control schemes. If I have it set up to also take gamepad controls and I pick up a gamepad and start playing with it, it switches immediately. Very nice, very handy. In some games, you can see you do that. Default map. Well, I don't want to default on tank controls. I want to default on gameplay controls. So I would pick gameplay. This isn't for the camera, and so we're just going to go down to here. Send messages, broadcast messages, and invoke Unity events and invoke C# scripts. There are different ways to use this action input system. Send messages is basically like it's going to call a function that you've defined in your code. Broadcast messages is your code has to find it, I think. Invoke Unity events is you put it in the Unity events. We're not going to do any of these things. Oh, invoke C# scripts is kind of the same thing. I'm not going to do any of these things. We're just going to leave it as send messages. I'm going to teach you how to use send messages. But there's definitely different ways to use how to do this. All right. Now for the dreaded computer science part of this. Let's open up our IDE. This is what's called an IDE. I believe it stands for Integrated Development Environment. Computer science majors might be tested on what that means, because I was. It's blank because I haven't opened up any files. So let's make sure we select the file that we want to work in. I earlier created a script called player movement. So we're going to go ahead and grab that one really quick. There's a little file button up there. Oh, and when you install Visual Studio, might look different because there are different themes. This is just the one I use. They all have the same locations, I think. This is not the right thing. This is Bierman's project. Don't worry about Bierman's project. Is it operating systems or embedded? Yeah, okay, that makes sense. I'm about to just dox my entire computer to you guys. Everyone knows it's everything in here now. Scripts. There we go. Unfortunately, VS Code does not use a Unity file explorer, so I really hope you know how to use your own file explorer. All right, when you create a script, it has these default things in them. For the non-computer science people, let me explain what's going on. Using Unity Engine, that means the scripts for Unity. We're using the Unity stuff. Public class player movement mono behavior. You can ignore most of that if you're not a computer science major. Just keep in mind what the thing is, because that's the name of your class. If you want to call something from this script somewhere else in a different script, you need to know that specific name. Otherwise, it's just kind of like, oh, public means any other file in your system can see it. And mono behavior is a type of script we made. Then you have the start. Hey, look, Unity gives you a comment of what it does. Its start is called once before the first execution of update after the mono behavior is created. Basically means when you initialize your project and you hit the start play button, it calls this once. Update is called once per frame. Every frame, it calls anything that's in here. So this is important for when you're coding. Keep in mind where the brackets are. That's the body of the function. So if I put something in here, it's called once per frame. If I put something out here, it is not called once per frame. Keep that in mind. All right. I like to use fixed update specifically. Oops, I can't spell still. Fixed update versus update is just kind of like if your frames are a little different between devices, it standardizes it just a little bit better. That's kind of all it is. Okay, moving on. I'm pulling up my references. We are going to make sure we use something else, because in addition to using the Unity engine, which is to say we are just making this code for Unity, we are also making this code to take inputs from our input system. There we go. Input system. Make sure you add that. It won't work either. Input system will not do anything if you don't have that. All right. We're going to keep going. Over here. Cool. I forgot to add a component. Back to Unity really quick because I forgot something. We're going to add a component to our player called a rigid body. That's just a bunch of mumbo jumbo to say it has physics. So if I add a rigid body and I hit play, it probably won't compile error. Probably. What should happen is gravity's applied because it has physics now, and gravity's a part of physics. But let's say we want a top-down kind of gameplay, and we don't want physics. Well, it's pretty simple. Let's look at the rigid body component. Well, it says gravity scale right here, doesn't it? If we just put 0 on it, well, we can't apply gravity if gravity scale is 0, right? I wish it compiled faster. There we go. Doesn't fall. But technically it still has physics. It'll feel resistance and whatnot. Anything else you need to worry about? No, not particularly. How many of you guys took physics? High school physics? Any of those kind of physics? Yeah, it's the same thing. It's all here. So I hope you remember some degree of it. Of course, it's simulated, so it's not real. But, you know, you kind of need to understand what the heck mass does. Anyways, moving back to the code. We want to make sure that we can actually get that rigid body component in our code, because we can add velocity to our rigid body. Physics. So we're going to go ahead and do that. Outside of the start function, I'm going to declare it. What that means, oh wait, private, not public. My bad. I can't spell. I don't always recommend naming your things like that. RB is kinda ambiguous. Name it whatever works for you, and your team, because your team might always look on your code too. Okay, what is that? Well, I said before that public means that any code in your system can look at this code. Private means only this code can look at code in this system. Basically, no other piece of code can see this rigid body thing. Great, but that's not actually getting the rigid body. That's just saying, I have a rigid body value. I don't know what it is, but I have one. I saw a hand or no? No? Okay. So we want to make sure we can get that. In the start frame, we're going to get that rigid body component. It is so much harder to type and talk at the same time. You don't have to worry about what the different syntax means if you're not computer science. Just kind of memorize it, I guess. But, I mean, it's kind of self-explanatory. That rigid body thing that we had, we know it's a rigid body. We know it's the physics. We're going to get that physics component, that rigid body component, from our object that this is attached to. So we're going to attach this script to our object as a component as well. All right, and that's basically all we do in our initialization. Very few things happen on the first frame, but you know, that's one of them. Well, what do we do with it? We can only get the movement, don't we? Well, let's create a new function. So outside of the start function and outside of the fixed update function, still inside the class, by the way, we're going to create a new function. Private void. What do we call our thing again? What was that action we called our thing in input system? This is where you have to remember the name of things and not type of thing. Player movement's close. I wouldn't be surprised if I called it move. Well, here's that action. The player controls, right? It's not the action map. We can always change action maps later. It's the move action. We want to call the move action. To do that, it's simply on move. Keep in mind the caps. Whatever capitalization you have in the name of the thing, note the capital M of move, just like it is in the action system. That capitalization has to stay. This is very case sensitive. Capitalize your O, otherwise it's not the right thing. That would be a syntax error. And here's your little brackets for the body and stuff. Different people code in different ways. I like to put my brackets down there. Inside these little parentheses, we have what's called a parameter. To explain that, it's basically this value is going to be given to this function for the function to use. Otherwise, that function doesn't have anything to work with. So, the input action system gives us that. Whenever it calls, so again, when you click one of these buttons, or a combination of these buttons, it becomes a 2D vector and calls the action move. Okay? Whenever it calls the action move, it's going to find the code. It's going to say, where is your onMove function? Here is the value that I just received from my inputs. You can name this whatever you want. I named it input. You can call it player input. You can call it key input. You can call it whatever you want. Inputs works for me. But input value is the name of what you're given. Okay, so we have it. But we can't do anything with that. That means nothing to us, right? We don't know whatever Unity code that input value actually is. It's some magic that took our buttons and turned it into a 2D vector. So let's get a value from that. Let's get that vector from it, right? If you're holding W and D, we want that diagonal vector from that input. To do that, we would just do input dot get syntax, pair syntax, and vector 2. Does that look kind of similar to something we saw earlier? Isn't that kind of similar to get components? And that's because it basically is, but not a component. It's just the value of vector 2. We are taking from inputs, we are getting the vector 2 value that came with those input buttons. But that doesn't mean anything either. We can't do anything with that right now. We have nothing to put that in. So let's store that value. Similarly to how we stored the value of our rigid body in our rigid body thing, we're going to do the same thing. So we're going to create a new, this is called a field or an attribute for the computer science majors. Know your terminology because that's tested on the AP exams, I guess. Vector 2D, nope, 2, vector 2. Call it whatever you want. Let's call it move input. I do my coding in camel case because that works for me. Do what you will. Underscores, whatever, just keep consistency. And I'm going to store this value in that move input. And that's how you store it. Just like the rigid body. It works, yeah. Semicolon. That would have been a syntax error. Uh-oh. I just opened up OneNote by opening up my pen, apparently. I didn't know I can do that, but that's pretty cool. All right. And that's how we get our inputs. So now we have an input. We have the 2D vector from it. We know the values now. We can make something with this. So let's come to fixed update. Now, every frame, if I happen to have every frame, if there is a call to input, but not necessarily connected, if there's a call to input, I have a value. So every frame, I'm going to check that value. And I want to make sure that I move my character accordingly. It's actually really simple. Our rigid body, we're going to give it a linear velocity. Hey, physics. Velocity. And that's going to equal our move inputs. That moves our character. But it moves it at the measurement that is the measured value in the input, which is, if you remember the unit circle kind of looking thing, 1. 1 unit. It's not very fast, is it? Or maybe it's too fast, and you want like 0.3 of a unit. So instead, let's make sure that we can actually control the speed. I want to be able to do it also from the engine. That way, I don't have to open up the code every single time. Unity has this really, really funny system, really fun, really awesome, called taking any public value and putting it into your engine. So let's call this move speed. I remember my semicolon this time. Thank you. Right. So public float move speed. This field means any other code can see our movement speed and can technically also change it. Whether that's useful or not, you decide. But what's more valuable is that this shows up in our engine. If you're used to old Unity, it might have been something called serialized field. We don't have to do that anymore, but it still works. And what I'm going to do, I'm going to take that move speed and just multiply it, because this is just a number. This is just a number. Well, technically this is two numbers, but we want to multiply it to both. And we will just move speed. If I can spell. That's our code done. We now have a top-down platformer in, well, 3 lines of actual code, 4 lines of like functions. Remember to hit Control S to save it, because otherwise it won't reload Unity. There you go. If you had an error in your code, say a syntax error, it would complain to you because it can't compile. That's what a syntax error is. It would say down here in this little tiny little black bar, you have an error on this line in this column. We think it's this error. I can show you, actually. If I just remove a semicolon, you'll see it. Let's remove a semicolon. In C++, no, not in C++, in C#, you need a semicolon at the end of any real line of code, because that's how it does things. So if I just, if I just remove the semicolon, I should have an error. Would you look at that? In this tiny little black bar down here, where my eyes have to squint to see, in this specific file, in this folder, okay? This is how you read a debug log. Assets folder, scripts folder, here's your file. That's how you find out where the problem is. On line 20, column 48, your code will tell you the line. You have to look for the column in a different location. There is an error. Semicolon expected. So you come to your code, you find whatever asset scripts play movement is. Find line 20. Would you look at that? And column 48. This is where it says so on Visual Studio. The column would be like this kind of thing. We're gonna add that semicolon back, so that way it compiles. But yeah, that's how you read an error. It tells you where the error is, tells you what line it's happening on, and it tries to give a guess at the best of its ability to see what the issue is. Now, can I move my player? Not quite, because we have to give him the script file as a component. This is another thing where they're using a little file explorer is really easy. You can click and drag it, which is really nice. Here you go, buddy. Please let me put it in. Please let me put it in. Right, nope. Right there. A little finicky sometimes, but you know, you can click and drag it, or you can type in the manual like script. I think you'd have to make a new one or whatever. I'm sure there's a way to do it. I just like clicking and dragging. Huh? Possibly. Okay. Remember how I declared movement speed public? Well, now it's here. Because it's public, I can make edits to it here, which is really nice and simplified that I don't have to open up the code every single time. If I want to make a small change or balancing, It's so simple. So this is called parameterizing your code, even though this isn't technically a parameter. Do it. It's helpful. It makes balancing really easy. Well, evidently, we don't want to multiply a move speed by 0, or else we're not moving at all. So let's give it like 10. Any generic number, and we see what it looks like. Let's run that code. Let's run that code, Unity. All right. Would you look at that? We can control it with WASD. You now know the bare minimum of how to make a game. Player controls, interaction, you're good to go. Well, we can do more than just that. We can have, let's say we don't want to top down. Let's say instead of moving, we want it to be a platformer. Well, a platformer is a little bit more complicated because now you actually deal with your physics other than just turning it off. Let's go ahead and start from the beginning, just so that you can see the process all again, now that you know what the end product looks like. Let's create a new scene. I don't know, let's call it the platformer scene. Why not? Generally, don't put spaces in your file names. I'm sorry? All right, whatever. I'm sorry? What is going on? Scene. Okay. A good practice is to not put spaces in your file names, because spaces are weird. Your computer doesn't like spaces. So try not to. Most of the time it works. 10% of the time it doesn't. And then you're like scrambling to figure out what's wrong, and it's like a random space or something. So if I click this, we lost everything. We're starting from scratch. But of course, you can always go back. Just click the other scene. Just click the other scene. And you can go back. So, same process. Yeah, what's up?
In the new scene, do you still have access to those scripts that you made?
Yeah. The scenes are in the same folder anyways, but that doesn't really matter where the scenes are, because any scene has access to any of the project folders. So if I wanted to, I can just create the same top-down. This is great for levels. We're gonna do the same thing. So let's create do 2D object. I don't know. I want a capsule this time. Why not? Capsules are kind of cute. wait. Watch this. I can make it like Dr. Mario for you. If we just I'm sure there's a way to do this. Let's add a 2D object. Nope, that's the rename. Wait, I don't know what that did. Add a 2D object, sprite, circle, child of the object, right? We just move it. Nope, just move this up. You'll see where this is going. I promise. Change this to here's your little color picker. If you click on this color thingy, you can make a new color. Red. Dang it, it's on the bottom of the thing. You can change the layer it's on in a few different ways by doing order in layer. Like that. You can make it higher. And how about sprites? A square. There we go. Make it the same red color, I hope. In layer 1 or 2 would work fine. Ta-da! Mario Pill! Dr. Mario Pill! Alright, that's how you make sprites without Acid Sprite or any other sprite working action. Yeah, you can do shapes in Unity. It works. Obviously, it's a little jank, but it works. Okay, let's actually do some things with this. So let's call the player again. So we have to add some components to it to actually give it some more personality apart from a sprite. Well, we need physics, right? If we want to move it, we have to add velocity. So let's add that rigid body. 2D, the other one's for 3D, but I guess you could use it in 2D too anyways. Just tends to be better if you do the 2D one for 2D projects. We actually want to keep gravity this time because we're a platformer. The rest of this is like, this can be helpful to take a look at. And constraints, the rotation. I don't know why rotation is part of physics, but I guess it is. If you freeze the Z rotation, it doesn't fall over. But we'll see if we can make it fall over. Why not? Apart from the rigid body, we need to add a controls. It was called player input, right? Player input. Well, we could use the same controls and use W to jump, but that control scheme gives us a 2D vector, doesn't it? We don't need a 2D vector. We just need the one left or right value and a jump value. So instead, we're just gonna make a new one. Why not? Nope, create. Input actions. Platformer actions. Bring this back down. Great. So, same process. What's the first step? Technically optional, but add a control scheme. Let's make sure we have the right devices. Keyboard. You still can't see it, but keyboard, I promise. There's a drop-down menu. You can add whatever else you want. I'll just add the keyboard. I should name it, actually. Keyboard, not mouse. There you go. I'm gonna actually click on autosave this time, so that way it saves while I'm working on it. I don't have to hit Control S every single time. Action maps, well, same thing. We don't want tank controls when we're walking around. We don't want walking around controls when we're in a tank. So, gameplay of like walking around. I'm going to just change this to a value on an axis. Was that the right one? Honestly, I don't even think you have to be honest. You could just do this. Just create a thing. Give it a positive, negative. There we go. Nope, didn't want to duplicate. Delete that one. Delete that one. Okay, I put in a left-right composite. Well, up, down, left, right composite was the combination of all of this unit circle looking thingy. A left-right composite is even simpler. It's just left and right. It's just the x-axis. So in essence, it's just a number. It's just positive or negative. Going back to here. If, say, both buttons are held down, we can choose which side wins between the two. I'm just going to say stops moving. You can add different kinds of things, like an interaction. Do I want this to be a hold, tap, press, slow tap, tap? That comes helpful when we want to do our jump. So let's go ahead and give ourselves these normal things really quick, because this is really fast and simple. Of A is for negative. D is for positive. So if I input D on my keyboard, I get a positive value. If I input A on my keyboard, I get a negative value. That's all this is. If I input both, I get 0. I'm then going to make a new action. This one's for jumping. For a jump button, right? You guys have a regular button for it. Is this a raise hand or a stretch? Got it. I understand. I've done that too. All right. A path, let's say spacebar. No, let's listen for the spacebar instead. Well, having some of these is pretty helpful for making your game feel a little better. Technically, you don't need to choose any of these interactions, but you know, a sneak peek in the game design, if you hit the space bar, you jump up. So if you just leave it like that, you jump full height every single time. What about if you wanted to jump half a jump? Well, you can let go of the space bar, and on most games, you jump half a jump. You start falling down. I won't show you how to do that, but I can show you how to do it in controls. And then you would just do a press interaction. And then you would want to see it's also a release as well. So lots of different ways to do things. And that's just how I would do it personally. Simple as that. I would add an interaction for a press type action, and I would make sure I get the value for it pressing and releasing. I'm not going to do that today, but you know, play around with it. Again, if you don't want them global for all your control schemes, you can flick them back to just being your keyboard and mouse. And great! Our controls are done! We can head back. Oh, wait. No one corrected me. We have to rename this. Or else we have to do on new action. And that's where a space would actually be really a problem. I don't know how you would define a name of a function with a space in it. So I would make sure you don't have spaces here. Okay. Controls are done. Is there a minimize? There's no minimize. Of course there isn't. Well, we're going to add the new script. Scripting. Model behavior. Platformer. Move. Oh, right click. Oh.
Yeah, you right click.
Well, hold on. I want to show you. Okay, great. You right click, you get this menu. You go to create, like you would for a file explorer, but then you have all these other options that you don't see in your file explorer, because you know your file explorer will have like Word, Microsoft Word here. You're gonna want to go to scripting. And then we want a mono behavior script. To be honest, I don't know what the others do. And that's what Google's for. Oh, I didn't mean to make a new one. Before we even touch the script, we can do a few more things with the components. If we run this, right, we saw that adding a rigid body gave it physics, so it had gravity. I love how Unity loves so slow sometimes. All right, right. So there you go. It has gravity, but all the pieces come with it because they're all part of the same thing. So let's make it not fall into the void, right? Let's give it a floor to stand on. Well, it should be simple, right? If I just create a 2D object, how about a big ol' square, which becomes not a square when I stretch it. It's going to be a rectangle. And just to make this like look different, here's pink. Surely it just stands on the platform, right? There is no collisions. Collision is a component. Okay. Well, we need a collision. Let's add for that. It's called a collider, a box collider. You can change the shape of it if you want it to look not like what it actually looks like. It can be helpful for sprites that don't have a good square shape, but you know, this is just a square. Okay, well, here's our details. It has a collider now, so surely it collides.
Wait a minute. You don't have collision.
You don't have collision. The player itself needs collision. So while the square has collision, the player doesn't. Okay. Another collision. Capsule collider 2D. Wow. Now, surely, we stand on the platform. The answer is yes, you stand on the platform. Let me zoom in a little bit over here. Great. So now we can stand on something, but we can't control it because we didn't give it a script, we didn't give it controls. So let's go ahead and do that really quick. Put this in earlier. Let's grab the right controls because that's the global one, and we don't want the global one. We want platformer. And again, same buttons, same settings, whatever you want. Okay, now we have the controls into this object, but we don't have anything to do with the controls. This is where the code's gonna get a little bit more complicated. Oh, yeah, I created, it's a component. It's called player input. Yeah, there's like 15 different types of input in that thing, so this is the one I'm using. I'm sure multiple will work. I just haven't played them all. And then you just click and drag your controls into it. Got it? Oh, the controls thingy down here in your file explorer, I just find the one that I just made and move it over. So this little section here is technically a drag and drop box. If you hold the right file type, you can just drop it in here. So I can show you again. I hold this and just drop it in to the right thing. Yeah. So let's work on that script, shall we? I'm a comp sci major and I dread doing this. Okay. Well, this is the wrong script. We don't want to do it here because this works fine as a top down. Let's make a platformer script. Did I make the script already? Did I make the script already? I don't actually remember. You saw platformer move? Yeah, that looks right. Thank you. Great. Same thing as earlier. It's just the stuff. So let's start with grabbing the right the input action stuff from Unity. The reason why using Unity Engine doesn't grab everything, and you have to do certain things manually, is because if Unity Engine grabs everything, it would take so long to compile because there's so many different options. So that's why it wants you to just like know what you want, so put it in yourself kind of thing. So we're gonna grab that input system again. We're gonna go make that rigid body field again. So private rigid body 2D, capitalize your D, rigid body. What else do we need? We need that player speed thing again, so move speed. I want to see it in Unity, so I'm going to call it public. It's a float value. Float value, to explain really quick, is basically a number with a decimal point. The decimal point can be 0.0. It's fine, but it's a number with a decimal value, because in computer science, you can't just use a number with a decimal value with a number without a decimal value, an integer. Some languages will throw errors, some will automatically cast, whatever. But float just means has a decimal value. Most of Unity works in floats. Let's call it move speed again. Well, what else might we need? We're gonna need our jump height or our jump power, right?
Jump height and fall speed.
Fall speed. Well, we could do fall speed. I'm not going to, but you could, because it has gravity scale already in the engine. But you can, if you put your fall speed here, you can actually change the engine stuff through code, which is great for if you're like using reverse gravity fields, you can make your fall speeds and negatives and stuff. Let's grab a jump power float. For both computer science people and not computer science people, it's good to plan ahead. I know a lot of people in computer science who just like to code, then go back and change things. It's good to know what you want first and then go back. Or not to go back. Good to know what you want first, set that all up, and then realize you need something later. So, you know, we're planning for that we're going to need jump power. Anything else we might need? Yes, you do need a way to tell if you're on the ground or not. Do we know how to do that yet? No, not really. Yeah, so to do that, you would do a public, it's called a layer mask. Now, what's a layer mask? Well, in Unity, your objects have a layer or a tag. We're just gonna say layer is ground. Nope, doesn't have a ground layer. We're gonna make one. So let me actually show how to get to that. So on the object, layer drop down, oops. Add a layer. I'm gonna call it ground. So we can check for the ground layer now. That's what we're gonna grab here later. We're gonna put in, I call it public because we wanna make sure we can decide what layer we're looking for. What else do we need? A ground, if this is our ground layer, we technically need a ground check. We're gonna do that with something called a raycast, and I'm gonna explain that in a second later. Raycast hits 2D. This means nothing to you right now. I'll explain it, I promise. All right. Yeah. That's most of it, I think. Oh, well, no, we need that that move input from the input system actions, right? So before we grabbed the vector 2D, right? In player movement, we just grabbed this vector 2D for move input. We don't have a 2D vector anymore. We just have a positive and negative value, which is a float, by the way. So we're going to do a float. And now we're most of everything. Oh, jump input too. We have a move input, we also need a jump input. Since it's a button is on or off. This is called a bool in comp sci, true or false. I know it's 7 o'clock, so I'm gonna start going a little bit faster on coding because a lot of this is stuff we've already done. So same thing. We're just gonna go grab that rigid body component during the start frame. And honestly, it might have been faster if I just typed it out myself versus copy pasting it. Didn't even work anyways. Rigid body is what happened to it? Rigid body is equal to get components. Did I spell it right? Yeah. The rigid body components. No caps there. Rigid body 2D. No. Rigid body 2D. Add the syntax. Da, 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 da. Great. Same thing as before. We're going to change this to a fixed update for the same reason as before. Well, kind of the same thing with our player movement. If we want the movement, we can grab that kind of thing here. But linear velocity is a 2D value. We only want one of the directions. We only want the x value. Surprisingly, it's simple. It's there you go, the x value. I want to make sure I put the right variable names in, because I did just copy paste this from something else. Yeah, it looks the same. Great. Okay. that's to move things. Let's grab that movement code again. So, just like before, looks the same, but a little different. We called our action move, so we're going to look for on move. Yeah, what's up?
Why don't you have just X? Why is it not Z?
Here? Because it's a 2D game. We don't have a Z value in 2D. Yeah, and we don't want the Y value because that's for jumping. Yeah.
Stopped.
Super Mario.exe. Again, we don't have a vector 2D value because we're not using a 2D left, right, up, down composite in digital normalized. So we're going to use a float. Right? So notice how things match up. Our move inputs gets a float value because our move inputs was declared as a float value. Our linear velocity x is a float value, so we're working with it with a float value. You'll get errors if you start trying to use vector 2Ds as floats. Very common error too. What's next? Well, that's left and right movement done. Should be at least. No compilation errors, so presumably no syntax errors. I don't think I added the script, so let me go ahead and throw that in. Right there. Right, nope. Right there. Move speed of like 10. Remember how we added the ground layer thing? We can decide which layer we're looking for. What's nice is when you put in a public layer mask, Unity knows you're looking for a layer mask, so it only shows you the layer masks. I made the ground layer a little bit earlier. Technically, you could do whatever. It could be water layer, but like, you know, be a little bit more descriptive. We're not going to have jump power because I didn't code that yet. So this should move left and right. Should, in theory, and we didn't do anything wrong. Yay! Oh, it fell over. We didn't lock the Z rotation. So I mentioned this really quickly earlier to freeze the Z rotation so you don't fall over. That's the exact reason why. All right. I think I'm going a little bit close in time here. I know they want to do the announcements after this. I'm gonna keep going fast. I'm sorry. Yeah. So the jump value, similarly to how we get on move, we do on jump. Private void on jump. Get the input value parameter. Inputs. Looks very similar because it is very similar to the move input. And we're just gonna go grab our jump inputs variable that we had earlier because we know we need one. Is gonna be whenever we press the button. That's how you know if an input's pressed. It's pretty simple. It's just this input, is it pressed? This returns a bool value, true or false, 1 or 0 in certain C languages, and our jump input's a bool. So that matches up. So now if we just throw into like fixed update, if we have a jump input, then we're just gonna add some linear velocity in the y direction. Again, float value because it's just the y-axis. And we had earlier jump power. This one, which is a float value. Awesome. I don't know why it's not lighting up. I sure hope I did it right. Oh, typoed. There we go. Yeah. So that should, in theory, just let us jump. Dang it, we can't jump. Oh, but I didn't give it a jump value, that's why. 10's probably a little high. We might go over. We might go into the skybox with this one. I mean, you could put 1 million on it, and we can jump. It's still going up because 10's a little high. Yeah. You want to make it higher? Let's make it 5 gravity. Let's make it 100 gravity. Or just just add some extra gravity, make this a little smaller. And try again. Welcome to debugging. Well, this is when you would grab your gravity scale and stuff and make sure that his linear velocity y is correct. Is there an easier way to do it? Why is he flying actually? Oh, maybe. I know why.
Yeah, I think if you overcompensate with the gravity scale and then jump power to set the speed of the jump.
Kind of. That would be a way to do it, but you'd still have a problem. The reason is I remembered, we didn't change this to false now, did we? This never becomes false. We check. Oh, we got the space inputs. True. Okay. To the moon we go. So our code thinks every frame. Oh, we have space input. 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 And we're just flying. Also because we don't have the ground check to say 1 jump per. So that problem can be easily fixed. If we go back to here, remember when I said you can use interactions? This is a great time to use an interaction. A press button, you press down the button, press and release. Now it realizes, oh, space is unpressed. False. And in theory, it should also just work. In theory, I sure hope it does, because I'm trying to go a little bit faster. Yeah, he falls now. But if I spam it, I can make him fly because we have no limitations on when he can input jump. He can input jump whenever he wants. So let's give that ground check a go. I'm going to change the gravity a little bit so you can see it a little bit more clearly. If I can find the rigid body and change it from 5 and 5, why not? Okay, ground check. I'm running out of voice here. Let's create a new function.
The jump input can only be true when after colliding with the ground.
Yeah. So the question is, how do we find when we're collided with the ground? Well, we knew we were going to need this. So that's why we have what's called the ground check as a raidcast 2D. What is a raycast? Well, a raycast is just a feeler? I don't really know what you describe it as. It's like, imagine my keys are my raycast. I create this raycast so that this direction below me, I will feel if it hits anything. And that's what a raycast is. So we're going to use that system to check if we're on the ground. There's a few different ways to do it, and raycast is one of the simpler ones. We're going to create a new function is grounded. If our raycast hits something, then we know we're grounded, right? Ground check, which is our raycast, is equal to physics 2D. Ah, I hate physics, don't we? Dot raycast. A raycast is a type of physics, apparently. There we go, some syntax. The parameters you put in here. That means the position of the object that has this script. So wherever our player object is, we have that transformative position. That's where the raycast starts. Then we want to know which direction the raycast goes. This is how we say up, down, left, or right. Vector 2 dot down, vector 2 dot up, vector 2 dot left, vector 2 dot right. We're going to need to give it a float value for how far it goes. I don't know how long our capsule is, so we're just going to have to try things really quick. Let's try 2.1, just so you can see the float value. F means float value. And then a ground layer. Which layer? We want to make sure it knows what layer to be looking for. We want to look for the ground layer, not the water layer, not whatever other layers we have in our world. Tree layer or whatever. And then we're just going to return this value. You could, in theory, just hit return in the front, but I'll put it down here. Great. Now we know whether something is grounded. We can just call this function. Okay, when do we call it? Well, when we get a jump input and we are grounded. Parentheses. Should be right. Yeah. Now it's only when we get a jump input and we're grounded. That's what the little double and means. This is double or for anyone who's new to this language. And yeah, that should work, I think. Of course, I don't know how far the raycast needs to go, so I might have a little bit more leniency than I should. But I just put a number and we'll see. Nope, didn't work. Well, we can see if our raycast is even reaching the ground. This is going to be the most important function that you will ever learn. It's called debug. Let us take a look at where this raycast is. My personal coding preference is I like to put debug all the way over here, so I know what my debug things are. I can remove them if I need it later. Debug. I'm gonna draw a ray. So there's different ways for debug. The other really important one that you should know is debug.log, and I'm going to show you what this one does. You pass in a string, and it just prints that string into the console. So we'll call it like check or something. I'll put it somewhere in a second. Transform dot position is going to look very familiar because it is just the same code that we use for the raycast. Vector 2 dot down. But this time the value is going to be put here with the multiplication instead of a comma. What do we put down? Like 2.1f? And let's give it a color so we can actually see it. This is going to happen every single second, so let's put this somewhere else. Let's put that in here. Okay. Now, where do you see your debug stuff? Well, you would see debug.log in the console, but draw a line isn't a console kind of thing, right? Where's draw a line? Well, if you run the code, obviously it's not in the playing field because then the player would see your debugs. Little thing up here says scene. This is how you see your raycast. Let me figure out how to zoom like this. Ah, so we should be touching the ground. Why can't we jump is a great question indeed now. But that's how you would see your raycast. It's in the little scene button. Could be, possibly. Sure. Let me just double check this is ground. Ah, it's not even, we created the layer and didn't even give it to it. That's a very, very small, simple problem that could have been fixed a lot earlier. Oops, my bad. Now let's try. Ah, there we go. You can also see that our little debug.log shows up in the corner. It also just shows up in console. Oops. Shows up in console.
Hell out of that check though, because
Oh yeah, absolutely. Yep. But you know how to do it. You all know how to do it. There you go. You just change the float value. And now you know how to make a top-down game or a platformer, whichever you prefer. The code's a little kind of wonky, but I hope that you kind of understood what I went through, and I went through it really quick. I'm going to ask for questions and hopefully give this back to the club so that they can make their announcements. Any questions? Yeah, what's up? Yeah, sure, I'll do that. I'll give him like a GitHub link or something. Yeah, because a file would be too big because it's Unity, so I can't just give you the Unity project. But I can give you basically this thing that we just did just now. And you can upload a link to GitHub. Awesome. Yeah. I know. I go a little bit fast because I was hoping to end this by like 7 o'clock instead of 7:30. All right. I'll clean this up later. You want to make your announcements now? Oh, sure.
yes, just take it off real quick.
Let me go ahead and stop the recording.